Good evening or good morning or good afternoon, depending on when you are actually watching this video and taking notes. We're going to go over section 10.2, so if you have your book, you can follow along, or just make sure you pause the video at any point to get everything that's on the screen written down. That's important. And then make sure you take advantage of going back and replaying everything so you have these down and you're good to go. So 10.2 deals with finding arc measures. So what we're going to look at first are some vocab. So here's some definitions. So the first one, hopefully a lot of it is kind of common sense. Some of it is going to be new. And that's okay. So the first thing that we're going to talk about is the central angle. So clearly it's the angle that's in the center of the circle. So just the more mathematical way to say that is you're looking for the angle whose vertex, remember that's where the two segments or the two rays meet at the vertex, and that's the center of the circle. So your central angle, make sure it's just in the center of the circle, the middle of the circle. All right, so in a circle, when you draw these central angles, you are going to see minor arcs. And what a minor arc is, well, just think of what minor means. It's small. So a minor arc is the arc that is smaller than half of the circle. Now remember, half of a circle is 180 degrees. So a minor arc has to be less than 180 degrees. Okay, so then this next sentence is really important. The measure of a minor arc is defined to be the measure of its central angle. We'll see some examples of this in a little bit, but just make sure you really understand that the measure of the minor arc is defined by the measure of that central angle. Okay. All right, so minor arc, we have those, and then of course we've got to go the other way and talk about major arcs. So if it's a major arc, it's big. So it has to be larger than half of the circle. So it's larger than 180 degrees. Okay, so one easy way to figure that out is if you have the minor arc, well, a full circle is 360 degrees. So all you have to do to figure out what the major arc is, just take the difference between 360 degrees and the measure of the associated minor arc. Okay, so hopefully that makes sense. Just take the total minus the piece that you have and you get the remaining. And then the last thing, hopefully you guys know this already, what a semicircle is. If I ask you for the degree, I've already said it, you're just going to tell me it's 180 degrees. Just the way your book words it is that it's the arc whose endpoints are the endpoints of the diameter, which hopefully that makes sense that you're going to call it half of a circle, so 180 degrees. Okay, so make sure you have those all down. And then we're going to look at some different examples. So if we look at measuring some arcs here, just a couple notes. So when we label angles, it's always better to label them with 3 letters, just to make sure you know for sure which angle you're talking about. So here we call the central angle ABC. Okay, so I can trace that and I know which angle that is. So here the central angle being angle ABC, that's 75 degrees. Okay, that's review right there. So now what we talk about is now going to the arc. So you see on the left, or the first picture, the angle's in red. Well, now what we're talking about is the arc. So we're talking about arc AC. So when we talk about arcs, for notation, you have to put literally just the arc above AC. Just like for an angle, you put the little arrow or the greater than, or the less than sign. Now for an arc, you're going to put the arc above the letters. Now, notice we're talking about a minor arc here, the minor arc AC. Okay, so it's a minor arc because this measurement right here, AC, I know this because it's being formed by the central angle of 75 degrees. So if I know this central angle measurement, I know it's going to be the same for my minor arc. So that arc, we measure it in degrees. Okay, it's not a length, it's a degree. Okay, so now if we switch gears and look at one last picture, and we go to the major arc, so notice what's red here. we're going to look at the major arc of this circle B. Now, another note in terms of notation, if you have a minor arc, you should have 2 letters for the arc. But for a major arc, you better have 3 because you need to know which direction you're going. Because if I were talking about this third picture, and I'm going to do this in a different color. If I were talking about this third picture and I wanted to talk about what's in red right now, but I said arc AC, well, you can kind of see that I can go this way with AC as well as what's labeled in red from A to C. I can go 2 different directions. So I've got to make sure that if I want to talk about the major arc, I can start at A and then I go through point D and end up at point C to make sure it's a major arc. Okay, hopefully that makes sense. So now if I want to know the measurement of that arc, what degree that is, all I have to do is take the total of 360 degrees and subtract the piece I already know. So if I know that the central angle is 75, that means, I should do some different color, that means that this minor arc in green here is also 75 degrees. So then this arc ADC, is just going to be the 360 degrees minus the 75 that I already know. So this degree is 285. Okay, so hopefully that makes sense. All right, so just make sure you are good to go on major arcs versus minor arcs. So there's a lot of arcs going on in this picture. So what I want you to do, I'm going to go through one of each. You've got to come up with the rest. So we're going to identify all of the minor and all of the major arcs in this one circle. So the minor arc that I will say is arc AB. Okay, that's one. Because I know that's less than half of the circle. Okay, so that's one. You need to come up with all of the rest, and there's multiple. And then for the major arc, that's going to be the arcs that are greater than 180 degrees. So I will say I'm looking at arc A, B, D. Okay, so that's one of them. You come up with the rest of the minor and major arcs. Okay, so make sure you have your list for tomorrow. I will be coming around and checking those, okay, in your notes. Okay, just like angle addition and segment addition way back when, we can add some arcs together. So here's one of our postulates for section 10.1. So this guy just says that I can basically add 2 arcs together. So if you look at this picture, if you want to know what the measure of arc ABC is, if you want to know what that equals, all you have to do is take, let me do this in a different color too. Just take the measure of arc AB, so that's in green, that's this guy, okay? And then I want ABC, so I want in blue, I want this total arc, okay? It's gonna look a little funny here. But then I'm gonna add the measure of arc BC, okay? So arc addition is just like angle addition and segment addition, to where you're taking 2 arcs and adding them together to get one big arc, okay? Hopefully that's common sense. All right, so what you're going to see with the activity we're going to do tomorrow in class, you're going to get a lot of these circle graphs. And we're going to ask you, hey, what's the measure of all of these certain arcs? So you just have to remember that when it comes down to it, a circle graph, all it is literally just a bunch of central angles, and I just need to figure out which central angle correlates to which arc. Hopefully that makes some sense. So let's go through A and B together. So this says A survey asked people how many minutes they spend brushing their teeth each morning, and then the circle graph to the right shows the results. So find the indicated arc measures. So we're going to go through A and B together. And then you'll do C and D, and I'll check those tomorrow when you get to class. Okay, so let's see. For 1 minute, we had 145 degrees. And then for 2 minutes, we have 120, 3 we have 82, and 4 we have 13. So I want to figure out what the measure of arc ABC is. So what I would do, if you're not fully seeing it, I would take a pencil or something and kind of color code this. So if I'm looking, I start at A and I go through B and I go end up at C. So all I need to do is figure out, hey, what is that angle what is that arc that I just formed? And all I have to do is look at the two central angles that it came from. So all I'm going to do is take 82 and add 120 to that, and I get a total of 202 degrees. Okay, so arc addition, just add them up and get your total. Okay, so hopefully that makes sense. And then let's go through B real quick. So arc ACB, and I'll do this in a different color. So now I got to go the other way because I have to start at A, go through C, and end up at B. So now I want this total in green. So just take 82 plus 13 plus 145, and you should get a total of 240 degrees. Okay, just add those pieces together. And again, if you want, color code. Make sure you can see what you're really looking for. Okay, hopefully that makes sense. Okay, so one other thing we got to talk about is identifying when you have congruent arcs. So it says if we have two circles that are congruent, okay, those are congruent if and only if a rigid motion, that should say, or a composition of rigid motions maps one circle onto the other. So think back to when we dealt with transformations. Rigid motion means I'm not changing the shape or the size. Okay, so everything stays the same. So the theorem 10.3 says two circles are congruent circles if and only if they have the same radius, which hopefully that makes sense, because if the radii are the same in the circle, I should have the exact same size circles. Okay, so here in this picture, AC is marked congruent to BD. So because I know that circle A is congruent to circle B. Again, I hope that's pretty straightforward, but if you guys have questions over that, we can certainly go over that tomorrow. All right, then the next theorem under identifying congruent arcs would be 10.4, looking at congruent central angles. So it says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. Okay, so as long as those central angles are congruent, trace those angles and the arc that's in between, or the arc that's formed, if those central angles are congruent, then those arcs should be congruent. So you can see in the picture that the angle CAB is marked congruent to angle DAE. So if I trace those, I just formed arc CB, and then if I trace this one, I formed arc DE. Okay, so since those are marked congruent by the central angles, I know that their corresponding arcs BC and ED are congruent as well. Okay, and then here are a couple examples, well, 3 examples here. So what I want you to do, I'll go through the first one, and then I want you to do the last 2 in your notes to be checked tomorrow. Okay, so what you need to do is you need to tell me whether or not the red arcs are congruent, and then make sure you can explain why or why not. So if we look at this first one, and I'm trying to figure out if this arc is congruent to that arc, okay? So take a minute and look at that and try to figure out, is arc FG congruent to arc EH? Okay, so what you have, going back to vocab here, are concentric circles. So you have one circle within the other. So what you have to stop and think, yeah, their central angles are the same because they're both being formed by 110, okay? But do we actually have congruent circles? And the answer to that is no, because the radius of the radii of these circles are not the same. This radius in red of this circle is going to be smaller than the radius of this circle in green. So you don't actually have congruent circles. So I can't say that those arcs are the same. Okay? Hopefully that makes sense. They have the same measure, but they are not arcs of circles that, but they are arcs of circles that are not congruent. So we cannot say that the arcs are technically congruent, okay? The other two should be pretty straightforward. So make sure you get those written down and completed in your notes. And then we will make sure to go over those two tomorrow, okay? So that finishes up 10.2 for you. So again, please go back and review anything that you might not have a good handle on, and then make sure you're jotting down any questions you still have, and then we'll certainly go over that tomorrow when you guys get to class. So make sure you bring those. All right, we'll see you tomorrow.